Guys, she's coming.
Hello Sheila. I hope our coffee was strong enough.
Thank you, Retrain.
Okay, let's get started.
Yeah, Sheila. Welcome to Edmund Optics. We're really looking forward to this meeting.
Thank you, Retrain. I am excited to be here.
Yes, that's it. So Sheila, let me introduce you to our fantastic team who makes the magic happen.
Welcome Sheila, I'm Shu. Get ready for some bright ideas. We promise a few light bulb moments.
Sound interesting, Shu. I'm looking forward to it.
Hi Sheila, I am Irene. Don't worry, I have locked up all the boring equations for today.
Thanks, Irene. I appreciate that.
Hello, I'm Jahid, the product engineer here at Edmund Optics. If you have any technical questions, feel free to laser them at me later.
Nice to meet you, Jahed. I'm sure I will have plenty of questions.
Thank you everyone for being here today. Sheila, at Edmund Optics, we pride ourselves on delivering top-notch optical components and systems. Our team is dedicated to innovation and quality, ensuring that you receive the best products and support. Let's start with a brief overview of who we are. Edmund Optics has been a leader in optical technology for over 75 years. We serve various industries including biomedical, defense, semiconductor and research, providing high-quality lenses, imaging system, laser optics and also optomechanical equipments. Our commitment to quality and innovation is what sets us apart. We use the latest manufacturing techniques and rigorous quality control to ensure every product meets the highest standards, whether it's custom optics or off-the-shelf components. We deliver solutions that are precise, reliable, and also tailored to your needs. Now Sheila, let me introduce you to the stars of our team. Irene, our R&D specialist, is an expert in innovation and development. She will share insights on our cutting-edge lens manufacturing processes. Shu, also an R&D specialist, will enlighten you on how we create prisms using simple yet effective analogies. And finally, Jahat, our senior engineer, will demonstrate the quality and durability of our products. So Sheila, shall we get started with the presentation?
Sure.
So Shuhara, would you like to take it from here?
I am curious about how you make your prism. Can you please explain it to me in simple terms?
Absolutely. Think of making a prism like baking a cake. It all starts with the right ingredients.
That sounds interesting. What are the ingredients for a prism?
So the main ingredient is optical glass. Imagine this glass as your cake batter. We start with a high quality glass to ensure the best result. For example, PK7s for general use, fused silica for UV applications, and F10s for high refractive index needs. These materials have excellent transmission properties and low dispersions, making them ideal for a wide range of optical applications. Each glass type undergoes rigorous quality control to ensure it's free from impurities and defects.
And what is the next step?
So, just like a bored cake batter into a mold, we shape the glass into a rough prism formed using special molds and tools.
So the glass is shaped, but it is not a prism yet.
Right after shaping, we need to bake it, so to speak. The glass is heated to remove any internal stress, making it stable and strong.
Got it. What comes after the baking?
Next, we need to decorate our cake, or in this case, refine the prism. This involves grinding and polish the surface using compounds like silicon oxide to make them smooth and precise. Precision is key to ensure the light behaves correctly when passing through the prisms.
So it is like frosting the cake to make it look perfect.
Exactly. Finally, we add any coatings to enhance the prism performance, like adding sprinkles on top of the cake. These coatings can help with refractions, or protecting the prisms.
That is a great analogy. So making a prism involves a lot of steps to ensure it works perfectly.
Yes, each step is crucial to produce a high-quality prism that meets our standards. Just like baking a perfect cake, attention to detail makes all the difference.
Thanks for the explanation. Now I understand how prisms are made.
You are welcome. I'm glad I could help. If you have any more questions, feel free to ask.
Can I know specifically about the research from Advanced Optics regarding the optical prism?
Of course, I will briefly introduce the research of our optical prism and explain the technology that drive Advanced Optics development and manufacturing. Our prism production uses advanced precision manufacturing technique. We offer a range of prism including right-angle prism, wedge prism, and equilateral prism. These prisms are meticulously crafted to perform tasks such as beam steering and image rotation. The precision in manufacturing ensures that each prism meets its specification, which is crucial for their effective performance in high-tech application. So, to achieve the highest standard, we employ advanced technologies such as ion beam sputtering, which delivers reflectivity greater than 99.99% and coatings that are stable under varying environment conditions. Our super polishing technique minimizes scatter loss and achieving ultra low surface roughness, which RMS value below 1 angstrom.
Well, does the prism meet our requirement in free contaminants?
Yes, our prisms are 99% free from contaminants. To address this issue, our in-house laser lab conducts extensive long-term UV laser exposure experiment to address laser-induced contamination, further enhancing the performance and longevity of our prism.
Unfortunately, our needs in optical prisms are technically involved in different angles, and some machines involved in two prisms adhering together. How do your company provide us with solutions?
Don't worry, our prisms are manufactured to consistently achieve sub-arc-second angle tolerance, specifically about 0.5 arc-seconds. These precise angle tolerance are essential as they ensure the correct angles between prism surface, which directly impacts system performance. So, in the case where two prisms need to be adhered together, we utilize Nolan NOA61, a UV cure adhesive known for its low shrinkage and excellent bonding strength. This adhesive is highly effective for application across the visible to near-infrared spectrum, and it ensures high transmission from 400 to 2000 nanometer. So, for your information, our volume production of prism takes place in Malaysia, ensuring efficient and high-capacity manufacturing. Meanwhile, our facility in Akita, Japan, with over 50 years of experience, focus on pioneering research to invent high-precision prism. Hopefully, this info may help you to understand our optical prism better.
Let's start with right-angle prisms. These prisms are used to deviate the ray path by 90 degrees, and they are also widely used in laser systems, microscopy, endoscopy, and medical instruments. So they come in materials like NVK7 and UV fused silica with coatings like aluminium, gold, and silver to boost their reflection of light.
That's interesting. What applications benefit most from these coatings?
Good question. The coatings enhance the light reflection efficiency. In laser system, a high reflective coating like silver or gold can minimize the light loss and boosting overall performance of the lenses. Next, we have anamorphic prisms pairs. These transform elliptical laser beams into circular beams. That is important for applications needing precise focusing. For example, like laser diodes in various optical systems, they reduce the beam's spot size, improving the system efficiency and also accuracy.
So, they are essential in systems where beam precision is key.
Exactly. They are indispensable in high-resolution laser printing and advanced optical communication systems. Furthermore, The dispersion prisms, such as equilateral prisms, they disperse white light into its component light colors. They are commonly used in spectroscopy, telecommunications, and for wavelength separations. Next, lateral prisms, a type of dispersion prism, can also tune multiple spectral laser systems when coated appropriately.
I have seen this in the spectroscopy setup. The color separation is quite impressive.
Yes, the precision in separating light into spectral components is the key for accurate analysis in many scientific and industrial applications. Also, we have beam displacement prisms that are used to adjust the light beam's position without changing its direction, which is useful in imaging systems to alter the beam path while keeping the original orientation. For example, some advanced binocular designs use rhomboid prisms to provide a longer optical path in a more compact form, enhancing the magnification without increasing its size.
That's innovative. It must help in designing more compact optical device.
Absolutely. It offers more flexibility in design without compromising performance of the lenses. Lastly, we have rotation prisms like dove prisms. They rotate an image without inverting it, which is useful in certain imaging and optical alignment applications. They are used in some telescope designs to rotate their image to match Earth's rotation or correct image inversion caused by other elements.
That's a clever solution for image orientation issues.
Indeed, it is all about maintaining the image integrity and orientation in various optical systems.
Thank you, Dean, for those insightful presentations. Now, Sheila, I hope this session has given you a clear view of what Advent Optics has to offer. Alright, Sheila, that's the end of our presentation. Do you have any final questions?
Yes. What is the most economically challenging project you guys have worked on recently?
Well, we recently developed high-precision optics for a budget-conscious consumer electronics product. Balancing quality and budget was quite a challenge.
How did you manage to save within budget?
We optimized our manufacturing process and source materials efficiently. We leveraged our supplier relationship to cut costs without compromising quality.
How do you ensure your products remain competitive in terms of cost and performance?
We constantly invest in R&D to improve performance and find ways to reduce production costs. We also do market analysis to keep up with trends and adjust our strategies accordingly.
Interesting. What about you, Jahed? How do you approach cost management in product development?
Okay. We use value engineering approach, focusing on maximizing their functionalities while minimizing their cost. We also collaborate across functions to identify the cost-saving opportunities during the stages of design and development.
How do your innovation translate to real-world economic benefits for your client?
We work closely with our clients to understand their specific needs and challenges. By providing tailored solutions, we help them enhance operational efficiency, reduce costs, and improve competitiveness. Our goal is to create a value that directly impacts their bottom line.
Thank you, everyone. I feel confident to collaborating with Advent Optics.
Thank you, Sheila, for your questions and engagement. To summarize, Advent Optics is committed to quality, innovation, and reliability. We value our partnership with you and are excited about the opportunities ahead. With Advent Optics, the future is always in focus. Thank you for your time today, and we hope to hear from you soon.
Thank you, Sheila. We are expecting a reply from you.
Sure, Mr. Rupert.